Hi, everybody. Welcome to topic number 16. In this topic, I want to talk to you about what's so-called the factorials and permutation. So in the previous topic, we learned we learned the principle of counting. So I'm going to continue kind of, expand a little bit on that counting idea. Um, so this is called factorials and permutation. Okay. Again, this is the way how we actually count. Okay. So what is a factorial? Factorial is given by this symbol called n factorial. N factorial is whatever this number is, you start out with that and then times by 1 minus, times by n minus 2, all the way down to times by 1. So if this will be like a 5 factorial, then by the formula, 5 factorial means 5 times 5 minus 1, which is 4, times by 5 minus 2, which is 3, then times by 2 times by 1. Okay. So what type of problems are dealing with factorials? Well, here's a good example. So let's say a doctor visits her patient during morning rounds, right? In how many ways can the doctor visit 4 patients? So think about this. So if the doctor is going to visit 4 different patients, okay? So this is patient 1, patient 2, patient 3, patient 4. Okay, 4 patients. So before the doctor go to 1 patient, that doctor has 4 choices, right? Has 4 ways, has 4 choices because there's 4 patients. That doctor has 4 choices to make. So once the doctor saw the patient, that doctor is probably not gonna go back again in that morning round. So when the doctor go to the second patient, then the doctor has 3 choices left to choose which remaining 3, which one she's gonna go see. So the second patient that doctor going to see, she will have 3 choices, right? So then the third patient, the doctor only have 2 choices left. Then of course, the last person is only 1 left. So one test followed by the other is a multiplication. So a factorial problem like this one is a perfect example of 4 factorial, right? Because I'm not revisit, okay? The order which doctor go see matters. Because once a doctor saw that patient, that doctor is not going back again, right? So the which order that doctor is going to meet her patient matters. So in that case, it's a factorial type of problem. So that will be 4 times 3 times 2 times 1. So if you put that in the calculator, I'm going to show you where is it. So you're tapping 4, then you go to math and highlight the word PRB. Highlight the word PRB. Go to the right. And number 4 is factorial symbol, which is 24. So the doctor has 24 ways can visit the 4 patients. Okay, it's kind of strange idea. Okay, it's kind of strange idea because when doctor made morning rounds, or let's say, for example, if you introduce yourself to 4 people, okay, there are 4 people you're standing in front of you, and you're gonna introduce yourself to each one. Then, then that means the first person you're gonna go introduce yourself with, you actually have 4 choices, which one you want to go see first. Then once you say hello to one person, then you're not going to say hello again because you just introduce yourself. So the second person you're going to say, introduce yourself. Now you have 3 choices. Okay, now then you have 2 choices, then you have 1 choice. So those kind of problems is considered as a factorial type of problem. Okay, it's a way to count. Permutations, okay, permutation is very similar to factorials. Okay, a permutation is a selection of objects from a group where arrangement is specific. Okay, so when I say the order that the doctor go see first matters. Okay, so that's referring to as arrangement is important. Okay, it's very specific. So when the order is important, then the formula is used to calculate the number of permutations. It's called NPR. The lowercase n stand for n distinct objects. The R is how many you're gonna select. So this example right here is, for this example, there are 4 distinct patients, right? choosing all 4 of them. R is how many we're gonna choose, because the doctor can go see all 4 patients. So this is actually 4 choosing 4 using permutation. So if I say it like that, I'm gonna show you how to punch in the calculator, okay? I know the formula is right here, but instead of doing the formula way, I'm gonna show you how to do it in the calculator. So 4 choosing 4 using permutation. So you type in number 4, go to math, highlight the word PRB, and then choose number 2. Okay, so now you got typing the selection, the R, which is 4. 4 choosing 4 is 24, just like 4 factorial. Okay, so permutation is where the order matters or the arrangement is specific. Okay. So I always use this example. Let's say I'm gonna select 2 students out of 20. Let's say I got 2 students in my class, out of 20 students, to go to Disney World. But the first person I select got to be the one to drive. So if I pick John first, then pick Jang next, then the order matters who I pick first because the first person got to drive. So John will actually be the one driving. If the order matters, then John, same 2 person I selected. If I would select Jang first, then select John, then Jang has to be the one that drive. So this will be a good example of a permutation because the order matters who I pick first, because the first person I pick, for example, is the one gonna drive. So this is 2 different ways. Okay, this is actually 2 separate ways. Even though it's the same person, same 2 people going to Disney World, but whoever I pick first is gonna be the one driving there. So the order matters. So that means this is 2 separate ways. Okay, it's kind of like an example. All right, let's try this example. A newly elected president needs to decide the remaining 6 spots available in the cabin that he or she is appointing. If there are 12 eligible candidates for these positions where the rank matters, so that means the first person will probably be the vice president, right? And then the next person can be the secretary. So the order matters. How many different ways, sorry about the typo, how many different ways can the member of the cabin be appointed? All right, so there are 12 distinct eligible candidates choosing for 6 spots. So that's 12 choosing 6 using permutation because the rank matters. That means who is being appointed first, second, third, all the way down to the 6th person, is go by ranks. Okay, so because maybe the first person appointed is going to be the vice president. Okay, the second one can be the secretary. So if the order matters, then we'll use permutation. Okay, so number 2, want you to write down how many ways. So the number 1 is on the homework will be type out, or write out the computation. The second one is going to be the answer. So I'm going to say 12 first, go to math, highlight PRB, and choose number 2. 12 candidates choosing 6 positions where the order matters, which is permutation. My answer is 665,280. Okay, so that would be that many ways can the member be appointed. All right, a coordinator will select 8 songs from a list of 9 songs to compose an event's musical entertainment lineup. Okay, so how many different lineup are possible? So does the order matter? Yes, the order, which song we're gonna play first matters, right? Because once we play that song, we're not gonna play it again. Okay. So which song is first, which song is second, third, fourth, all the way down to the 8th song. Okay. The order does matter, of that lineup. So if the order matters, then we would use permutation. So that's 9 songs total, choosing 8 of them. So that's 9 NPR, choosing 8. And let's see what that is, okay, in a calculator. 9 first, math, go highlight PRB, choose number 2, choosing 8 songs. So that will be 362,880 different lined up. Okay. So when the problem where, in these for these problem, if the order, which one go first, second, third matters, then those are permutation. All right, let's try this example. This one is a little bit tricky, okay? Tell you what, I'm gonna do the last one first, then I will come back to that one. All right, let's say you need you need to have a password with 6 letters followed by 3 odd digits between 0 to 9 inclusive. If the character and digit cannot be used more than once. Okay, so that's very similar to the permutation we just deal with, right? Okay, the digit cannot be used more than once. So that means once I use a letter X, I can never use it again. So that means which letter I use first matters. So the order of my letters matters. Okay, the order of my 3 odd digits matters. If the character and digit cannot be used more than once, how many choices do you have for your password? Okay. So remember, there are 26 characters, right? 26 letters, and I need to choose 6 of them. And the reason why I'm using permutation is because the order which letter I use first matters, because I cannot use, once I use one letter, I cannot use it again. Okay, so the choice does matter. So we actually in other video I mentioned something about the license plate. I think it was in topic 15, where there was an example of license plate that was 3 number followed by 3 letters. Okay, in that particular problem, it does say the repetition is allowed. So if the repetition is allowed, if you use one letter and that letter can be used again, that means each time, let me do it right here. 1, 2, 3, 4, 5, 6 letters, right? If repetition is allowed, then each letter we have 26 choices, but we really don't, because if the letters cannot be repeated, cannot be used more than once, that means the first letter I put, I had 26 choice. The next letter I had 25, then I had 24, then I got 23, 22, then 21 choices for the 6th letter for the password. So this is the same thing as saying 26 choosing 6 letters using permutation. 26 letters choosing 6 of them, right? 1, 2, 3, 4, 5, 6 letters. And now I'm gonna follow by 3 odd digits from 0 to 9 inclusive. From 0 to 9 inclusive, odd digits are 1, 3, 5, 7, and 9. So that means there are 5 odd digits. So this is followed by 5. Then this is followed by 3 odd digits. So odd digit from 0 to 9, there's 5 of them. So when it comes to the 3 digit, the first digit I put, I should have 5 choices, right? 1, 2, 3, 4, 5. Then once I use one of these odd number, I cannot use it again. So then in the next one, I only have 4. Then the next one, the last odd digit, I have 3 I can choose from, right? I have 3 of them I can choose from. So the 5 times 4 times 3 is very similar to 5 choosing 3 using permutation, because the order which number I use first does matter. Okay, so I'm gonna show you how to put this in the calculator, okay? You don't have to do this, but it'll be safer if we do it. Put the 26 choosing 6 permutation in a parenthesis. All right, open parenthesis, PR, NPR, choosing 6, close the parenthesis, then times, open parenthesis, 5, choosing 3, close parenthesis. That's how many ways. So what happened if I would type in what I just wrote down here, 26 times 25 times 24 times 23 times 22 times 21 times 5 times 4 times 3. You see, I get the same answer. Okay. So number 2 here, the answer is 9, 945, 936, 000. So that's 9,945,963,000 ways. Okay. The order matters, then that's a permutation. Okay. This is a cute little problem right here. If you are getting a lineup ready for a school kickball game, let's say we have 5 girls and 5 boys. The rule states that each child must kick the same number of times. And we're also going to alternate girl, boy, or boy, girl. Ooh, let's make it interesting. So how many ways can a lineup be made for one round? I'm just doing one round of kicking. Okay. So every kid got to kick, all 10 child got to kick, right? All 10 child got to kick. All 10 child got to kick, and everybody will only kick one time. So think about this. I have 5 boys. This is 5. This 5 means 5 boys total. And all 5 boys got to kick, right? So how many ways can I pick those 5 boys? And the order matters, which, or the order matters. And plus on top of that, think about it though. If I would pick, I got 5 kids I got to pick from. So the first kid, the first boy I pick, I have 5 choices. Then the next one, I only have what? I only have 4 boys left. So I have 4 choices to pick. So the order is important. So this is 5 choosing 5 because all 5 boys got to kick using permutation because the order does matter. All right. So that's just for the boys. This is just picking the boys, followed by, right, by the counting principle. I know I got to multiply here, followed by 5 girls, and I'm going to choose all 5 of them. Okay, using permutation, same thing as earlier. Okay, so this is boys, this is girls. Okay, this will give me so many ways to choose the boys, followed by this many ways to choose the 5 girls, where the order matters. Who kick first matters, right? Now, the toughest part is right here, the alternate part. It got to be alternate girl, boy, or boy, girl. So what I just described was boys followed by girls. So that means I should also have a girls followed by boys. So instead of writing, instead of writing this again, I'm just gonna take this times by 2, right? Because I had to alternate. I gotta do boy, girl, or boy, boy, or boy, girl. So I got 2 of the same exact lineup. Well, two of the, not the 2 exact same lineup, 2 of the same exact computation, basically. Okay, so this you can imagine this is the boy, then followed by girl. So if I would do girls followed by boys, I will write out exactly the same computation because the word or I will add the 2. If I calculate them separately, I would just add the 2 together. So instead of adding the 2 the same answer, same lineup, I just go ahead and times by 2. Maybe that's easier. All right, so let's see what my answer is. So this one is a bit tricky, right? This is 5 choosing 5 already inside the parenthesis. So I'm gonna just type in exactly what I see. 5 choosing 5 times 5 choosing 5 close parenthesis, then times by 2, right? There you go. 28,800 different ways. So there are 28,800 ways we can line up for just one round of kick. Okay. All right, let's look at some homework. So this is one definition. So this question number 2 is very similar to the one I have 4 patients. So write all the scenarios and for number 2, enter the answers and please use graphical equation. This one is similar to the one I just did about the 12 cabinets, because this is actually 5 spot, 10 candidates. All right, so this is similar to the songs, the example I just did earlier with the songs. And here is your the password, 4-letter followed by 4 even digits, 0 to 9 inclusive. Okay, so you can just write out the scenarios, type out the scenarios and enter the answers. Okay, enter the computation and then you can also and then number 2 will be entering the answer, just like what I wrote basically. Okay, so just real quick, kind of explaining what a factorial is and how we can use permutation to compute the number of ways we can do arrangement. All right, thank you for watching.